Hello everyone, it's Peter here, Piotr Fessner, with another update from my messy workshop. Anybody is welcome to come and help me tidy up. Got no space to put stuff. But anyway, going back to the topic. So, yes, it's a fourth, I think, episode of building an inverter. Pure sine. That's the ultimate transformer. This is a 60 volt ampere core used here. It's a 400 watt continuous power. It's a 24 volts input, 50 hertz output, 230 and 240 volts, extra 12 turns here, and thermal fuse 5 amps and 130 degrees. This is capable of working in the 100 degrees all the time, so it's quite a nice thing. And the first edition, I'm building the Electronoops one. I'm waiting on a few parts because I thought I will have everything, and I'm waiting. So yeah, I had to use more solder on these, add up, remove it from all these. I found as well issue here which I didn't know about. It has a switch on. Yes, the first one which came is faulty, because I've ordered first and then I've ordered 3 after that. So the first one had tilt capacitor didn't hold, well, not even 4000, it's 4700 microfarads. It didn't hold at all. So yeah, I bought 10 just in case, and there is a switch here, those two thingies, it's a switch. Oh, those, you need to short them in order to turn it on. If you don't, or if you don't have switch, it won't turn on. So yeah, me dummy. Yeah, so now when you buy it, you'll know it. And the next 3 which came here, you see it's knackered here. So I've said at least one refund me, because you know, either send good product, or if you're sending something that here is missing completely on this side. Yes, whereas on this side, you see this is, they could pack it well, they could send you with a good capacitor. They send what they sent, so I said one has to be refunded out of 4. That's 25% discount on 4 of them. Yes, in total. When you buy one, it's dearer. If when you buy more of them, it's cheaper, depend on the seller, of course. So if you plan to build one, you know, maybe buy 2 just in case, so it will be lying somewhere on the shelf and it's fine. Now these ones first transform the power, like power inlet, and then you get a controller. Then this controller drives MOSFETs. It's 3205s, and now what's happening is it's automatically transformed to the high frequency. It's either 16 or 20 kilohertz. Yes, a transformer. Now this one is rectified here again. Yes, and goes to the capacitors here, shunt resistor. Here is controller, and this controller then can control the feedback system, IGBTs here, and get some protection as well. It requires 2 stabilizers as well, this EGS002 board. So you've got L7Os here. So it's not that really complex, but that's the first one from Electronoops. On his YouTube channel you can find it. I still got some PCBs, so if somebody wants only one PCB, they can contact me, especially if you live in the UK. And that's the first project, and the second project will be that one. So I'm looking into those topologies, like half a bridge, full bridge, push-pull. So I've chosen for now half a bridge topology, and mine will be a bit different design. So I'll show you what I've chosen as a solution. So it's here, As we see, it's DC 12 or 24 volts. In my case it's 24 volts input because I've got two batteries in series, so it's 24 volts input, and then we've got 230 240 output at continuous 400 watts. Yes, so first stage is the input. Yes, we got an input, and then we've got a protection, then SPWM, so it's a sinusoidal pulse width modulation. We can use either EGS002 or custom controller, may make it ourselves, yes, and code it, of course, if you wanna. Then use transformer. So then you see my design is that I will use low power here and transformer, and then there is a feedback, protection, and output. I don't want to use those IGBTs at the end. I want to use regular toroidal transformer. I've seen it in the Victron Energy, I've seen in the Deer projects that the output has to be toroidal rather than those IGBTs, because you've got two types of the design. You are either taking, like here in this one, yes, you take it to the higher voltage, and then, you know, make the pure sine out of it here with IGBTs, or you take into the 50 Hertz yourself, this SPWM, then not PWM, not pulse width modulation, just plain, and then you've got this 50 Hertz transformer which you use on the output. Now in the favor design I will probably add some Wi-Fi or ESP32, especially if I'll use my own controller, but that's not at the start. At the start my goal is to have efficiency over 80% inverter, and which this I've heard it works. So I will build this one first, and then I will do this my design, so SPWM, not PWM, and 50 Hertz transformer. Yes, that one. What I can say as well, that's it, guys. So yeah, I've got a transformer. I'm building this one. I already soldered components. For those who never done this, if you go into to remove those components, like me, if you don't have practice with soldering, guys, use enough heat, okay? Don't pull those components hard. Try to heat up well. And if you've got transformer, I use suction pump. Yes, I use suction pump, heat up, remove solder, then you can even add flux if you wanna. It will be smoky a bit, but you can use flux. Remove that one, and remember that's 230 or more volts. It can kill you, so you're the person responsible if you wanna do it. Yes, that's not to play. That's not a toy, 12-volt toy. So don't do it if you don't know what you're doing, or you can get killed, because I don't want to be drug after that for that. But again, enough heat has to be applied. Yes, because if you don't use enough heat, you won't pull these components. Now if you have third hand, that's a useful thing. If you don't have, you'll struggle. You can buy these cheap on AliExpress, you can buy them on eBay, I think, as well, or Amazon. Just use this one, and this then can hold here, and you can work on it much better. Yes, just a wee advice for those who don't know. Yes, so we've spoken about the topology, half bridge, we've spoken about SPWM, low voltage to the sinusoidal wave from it, and then transformer, so you know it, what I'm planning to do. And I think for now, yes, for now, I will only focus on this one from now on, because I want to finish this one, so more updates will be on this. Once those two components will come, I can put it on, switch it on, see if I've got power, then can add, I don't have a switch here, that can come from China in a long time, doesn't matter. Then we need EGS002 installed, and all those components here on the side with shunt resistors, with electrolytic capacitors, bridge rectifier here, and then IGBTs, yes, and then choke and a capacitor here. Two capacitors, actually, these are two capacitors. Here is a choke and here is a big coil, yes. So again, this won't be a perfect and ultimate inverter, but that need to be done, because that's a pure sine, that's the first form of pure sine. And then I'll close this topic for now, and I'll focus on that one. That's the plan, guys. That's everything what I wanted to show you. You know where we are, you know what to do or what not to do. That's up to you. And I'll make everything available when I will finish it. I'll talk through the stages in one summary video as well. But what else I can tell you? Oh, when this will be running, you need to have some radiator here. This design is poor, by the way. It's done like this. Here, why you would put capacitors above IGBTs? They can get hot. If they can get hot, guess what will happen? You need a heat dissipation, you need a radiator. So putting here rather than in front of them, where you've got space in front of it, yes, and using multi-layer, because it's 2 layers PCB anyway, you know, that's for me, you know, I'm no expert with design, don't get me wrong, I can only fix some stuff and that's it, but that's it. And then I've seen one other flaw with it, don't remember which one, but yeah, and these ones, why you would put here not, you know, not enough space, maybe put them on the outside and controller inside, you know, so that you can put here radiator, yes. Again, I'm no expert in designing, but I think those two things, if you design things and you put in the center things which you know you need a better heat dissipation, you know, that's maybe me, and maybe I'm wrong. Comment down below and if you know better. But thank you for watching, and see you in the next video. Bye bye.